More than 300 million years ago, Earth looked very different from today. Almost all the land was connected into one huge supercontinent called Pangea. It included large deserts, thick forests, rivers, lakes, mountains, and long coastlines. As time passed, many kinds of dinosaurs appeared and spread across these connected lands because there were few barriers between different regions. They searched for food, hunted, raised their young, and adapted to changes in climate and the environment. Over millions of years, the land slowly began to break apart, changing where dinosaurs could live and travel. Pangea was a huge landmass that joined almost all of Earth's land into one connected continent. Instead of the separate continents that people know today, nearly every major piece of land was linked together. Mountains, forests, rivers, deserts, lakes, and wide plains were all part of one enormous stretch of land. Animals could move across very long distances without crossing large oceans because there were no wide seas separating most of the land. Plants also spread across large areas as seeds were carried by wind, water, and animals. Pangea was one of the most important stages in the long history of Earth because it shaped the land, climate, oceans, and the living things that existed at that time. Scientists believe that Pangea formed during the late Paleozoic era after many smaller continents slowly moved toward each other over a very long period. The process took millions of years because the surface of Earth is always moving. The solid outer layer of Earth is broken into large pieces called tectonic plates. These plates move very slowly across the softer layer beneath them. Although the movement is so slow that people cannot notice it in daily life, it has changed the shape of Earth again and again throughout its history. As the plates moved, continents slowly came together until they formed one giant landmass. This giant landmass became known as Pangea. The name Pangea comes from ancient Greek words that mean all Earth. The name was chosen because the supercontinent included almost all of Earth's land. Only a few smaller pieces of land remained separate. Around the outside of Pangea stretched one enormous ocean that covered much of the planet. This great ocean surrounded the giant continent on nearly every side. Inside the supercontinent, there were smaller seas, rivers, lakes, and wetlands. But most of the world's open water was part of the great ocean surrounding the land. Scientists think that Pangea existed from about 335 million years ago until about 175 million years ago. During that long period, Earth looked very different from today. The familiar shapes of Africa, South America, North America, Europe, Asia, Australia, and Antarctica did not exist as separate continents. Instead, they were connected as one large body of land. If someone could have looked at Earth from space during that time, the planet would have shown one massive continent surrounded by a huge ocean. The story of Pangea is closely connected to the movement of tectonic plates. Earth's outer shell is made of rocky plates that slowly drift across the planet. Deep inside Earth, heat causes material in the mantle to move. These slow movements help push and pull the plates over very long periods. As the plates shift, continents move with them. Sometimes they move toward each other, at other times they move apart. This movement has continued throughout Earth's history and is still happening today. When continents move toward each other, they may collide. Such collisions can create mountain ranges as huge masses of rock are pushed upward. Some mountains that exist today began forming when pieces of land came together during the making of Pangea. These mountains have changed greatly through weathering and erosion over millions of years. but many still remain as part of Earth's landscape. The inside of Pangea was very large and was often far from the cooling effect of the surrounding ocean. Because of this, many inland areas became dry. Rain did not always reach these distant places because mountain ranges blocked moist air coming from the sea. Some parts of the supercontinent experienced long dry seasons. Other areas received enough rainfall to support forests, rivers, and many forms of life. Different regions of Pangea had different climates depending on their distance from the ocean, their height above sea level, and their location on the planet. The northern and southern parts of Pangea experienced different weather conditions because they were located at different distances from Earth's equator. Areas closer to the equator were generally warmer throughout the year. Tropical forests, swamps, and rich plant life grew in many of these places. Areas farther from the equator experienced cooler temperatures. Some regions even showed signs of ice during certain parts of Earth's history. These changing climates affected where different plants and animals could live. Life on Pangea included many kinds of plants. Large forests covered parts of the land. Ferns, seed ferns, horsetails, conifers, and many other plants grew across wide areas. Some plants reached great heights, while others spread close to the ground. Wetlands supported thick vegetation, providing food and shelter for countless living things. Fallen leaves and dead plants collected in swamps, where they slowly became buried under mud and other materials. Over long periods, some of this buried plant matter eventually changed into coal. The animals that lived on Pangea included insects, fish, amphibians, reptiles, and many early relatives of dinosaurs. Insects grew in large numbers because forests and wetlands offered many places to live. Rivers and lakes were filled with fish and other water animals. Amphibians thrived in wet environments where they could reproduce. Reptiles became increasingly successful because they could survive in drier conditions. Their eggs had protective shells that allowed them to reproduce away from water, helping them spread across many parts of the supercontinent. As time passed, reptiles became more varied. Different groups developed features that allowed them to live in forests, deserts, river valleys, and open plains. Some remained small while others became much larger. They fed on plants, insects, fish, or other animals depending on their bodies and surroundings. These reptiles formed an important part of the living world that later gave rise to many other groups of animals. The world of Pangea was not quiet or unchanging. Volcanoes erupted in some places, sending lava across the land and releasing gases into the atmosphere. Earthquakes shook the ground as tectonic plates continued their slow movement. Rivers changed course over time, carving new valleys and carrying soil across the landscape. Wind shaped deserts by moving sand from one place to another. Rain wore down mountains and carried broken rock into rivers and lakes. Every natural process slowly changed the appearance of the land. Scientists did not always know that Pangea had existed. For many years, people believed that the continents had always been where they are now. As maps improved and knowledge of Earth's surface increased, some people noticed that the coastlines of certain continents seemed to fit together. One of the most striking examples was the eastern coast of South America and the western coast of Africa. Their shapes appeared to match in many places, leading some people to wonder whether they had once been joined. The idea became much stronger during the early 20th century, when the German scientist Alfred Wegener carefully studied many kinds of evidence. He suggested that the continents had once been joined together in a giant supercontinent and had later drifted apart. Many scientists at first rejected his idea because he could not fully explain how continents moved across Earth's surface. At that time, the movement of tectonic plates had not yet been understood. Wegener gathered many different kinds of evidence to support his idea. He found fossils of the same plants and animals on continents that are now separated by wide oceans. It was difficult to explain how the same species could appear on distant lands if those lands had always been far apart. The discovery made much more sense if the continents had once been connected. Scientists also found rocks with similar ages and structures on different continents. Mountain ranges on one continent lined up with mountain ranges on another when the continents were placed together in the shape of Pangea. These rock layers suggested that the land had once formed one continuous area before later breaking apart. Another important clue came from ancient climate records. Scientists discovered signs of glaciers in places that are now warm. They also found evidence of tropical plants in areas that are now much colder. These discoveries showed that continents had changed position over very long periods as they moved across Earth's surface. Later discoveries about the ocean floor provided powerful support for the idea of moving continents. Scientists found long underwater mountain chains where new ocean crust forms. They also discovered that the rocks nearest these underwater ridges were younger than rocks farther away. This showed that the ocean floor slowly spreads outward, carrying tectonic plates with it. These discoveries helped establish the modern theory of plate tectonics, which explained how Pangea formed and later broke apart. The breakup of Pangea happened gradually over millions of years. Large cracks began to appear in the supercontinent as tectonic plates started moving in different directions. Molten rock rose through these cracks, creating new ocean crust. As new crust formed, the land slowly separated. Oceans widened between the drifting continents, making travel between them impossible for most land animals. At first, the separation was small, narrow seas appeared between sections of the land. These seas slowly became wider as the continents continued moving apart. Rivers changed direction, coastlines formed, and new marine habitats appeared. Plants and animals found themselves living on lands that were becoming more isolated from each other. As the continents drifted farther apart, different groups of living things followed their own paths of development. Populations became separated by growing oceans. Over long periods, they adapted to the climates and environments of their own regions. This helped create the wide variety of plants and animals that later lived across different parts of the world. The oceans surrounding the separating continents also changed. Ocean currents developed new paths as land moved into different positions. These currents carried warm and cool water around the planet, affecting rainfall, temperature, and weather patterns. Changes in ocean circulation influenced life in the sea as well as on land. The atmosphere also changed over time. Volcanoes released gases into the air, while plants absorbed carbon dioxide and released oxygen through photosynthesis. These natural processes affected Earth's climate over millions of years. Changes in climate influenced where forests could grow, where deserts expanded, and where animals could survive. Pangea played an important role in the history of dinosaurs, because some of the earliest dinosaurs appeared while the supercontinent still existed. Since the land was connected, many early dinosaur groups could spread across large areas without crossing wide oceans. Fossils of related dinosaurs have been found on continents that are now very far apart, because those continents were once joined as part of Pangea. The earliest dinosaurs were generally small compared to many of the famous dinosaurs that appeared later. Some walked on 2 legs, while others eventually developed bodies suited for walking on 4 legs. They lived alongside many other reptiles, early mammals, insects, and countless kinds of plants. Their world included forests, floodplains, river systems, deserts, and open landscapes that stretched across much of the supercontinent. Early mammals also lived during the time of Pangea. These small animals were often active at night and fed on insects, seeds, and other available food. Although they were much less common than many reptiles during this period, they survived and continued developing through changing environments. Their descendants later spread across the world after the dinosaurs disappeared. The seas around Pangea contained many forms of marine life. Fish of many kinds swam through the oceans. Sharks hunted other sea creatures. Shellfish, corals, sea lilies, ammonites, and many other marine animals filled shallow coastal waters and deeper parts of the ocean. These ecosystems supported rich food chains that changed as the continents slowly drifted apart. Earth has never stayed completely still. The ground beneath our feet may seem solid and unchanging during a human lifetime, but the surface of our planet has been moving throughout its history. These slow movements happened over extremely long periods of time and changed the shape of the continents many times. One of the greatest results of these movements was the formation of Pangea, a single giant landmass that brought together almost all of Earth's land into one connected area. The story of how Pangea was formed is the story of Earth's moving outer shell, the forces deep inside the planet, and the slow joining of many smaller pieces of land into one enormous continent. The Earth is made up of several layers. At the center is the inner core, which is surrounded by the outer core. Above the core is a thick layer called the mantle. The outermost layer is the crust, where all continents, oceans, mountains, rivers, forests, deserts, and living things exist. The crust and the uppermost part of the mantle form a hard outer shell called the lithosphere. This hard shell is not made of one single piece. Instead, it is broken into many large and small sections called tectonic plates. These tectonic plates are always moving, although they move so slowly that people cannot notice the movement from one day to the next. In many places, the plates move only a few centimeters each year. This movement may seem very small, but over millions of years, it becomes enough to change the positions of entire continents. The plates float on a softer part of the upper mantle that can slowly flow over time. Heat from deep inside the Earth keeps the mantle moving, and these movements help push and pull the tectonic plates across the planet's surface. Scientists believe that the heat inside the Earth comes from two main sources. Some of the heat has remained since the Earth first formed about 4.5 billion years ago. More heat is produced by the slow breakdown of radioactive elements inside the planet. This heat creates movement within the mantle. Hot material rises toward the surface, while cooler material slowly sinks deeper into the Earth. These slow movements are called convection currents. Although they move very slowly, they provide much of the force that causes tectonic plates to change position. The movement of tectonic plates happens in different ways. Sometimes two plates move toward each other. Sometimes they move away from each other. At other times, they slide past one another. Each type of movement changes the Earth's surface. When plates move toward each other, mountains can rise, volcanoes may form, and one plate may sink beneath another. When plates move apart, new crust is created as melted rock rises from deep inside the Earth and hardens. When plates slide past each other, earthquakes can happen as the edges of the plates rub against one another. The formation of Pangea did not happen quickly. It took hundreds of millions of years for many different pieces of land to slowly move toward one another. During this time, continents that had once been separated by wide oceans gradually came together. As the plates carried the continents across the Earth's surface, the distance between them became smaller until they finally met. The continents themselves do not move through the oceans. Instead, they are part of the tectonic plates. As the plates move, the continents resting on them move as well. This process is called continental drift. The idea of continental drift was first suggested in the early part of the 20th century by the German scientist Alfred Wegener. He noticed that the coastlines of several continents seemed to fit together. He also found that fossils of the same plants and animals appeared on continents that are now separated by wide oceans. Although many scientists first doubted his ideas, later discoveries about tectonic plates provided strong support for his explanation. Even before Pangea existed, Earth's continents had already been moving and changing their positions many times. Smaller landmasses formed, broke apart, and joined together again. The history of Earth's surface includes several earlier supercontinents that existed before Pangea. Each one formed through the movement of tectonic plates, and later broke apart as those plates continued to move. This cycle of joining and separating has repeated many times throughout Earth's history. The rocks that make up the continents are generally lighter than the rocks beneath the oceans. Because of this difference, continents usually remain above sea level, while ocean floors stay lower. Even though continents are lighter, they are still carried by the tectonic plates beneath them. As these plates moved closer together, the continents slowly approached one another until they became connected. Many different continents played a role in the formation of Pangea. Pieces of land that would later become Africa, South America, North America, Europe, Asia, Australia, and Antarctica slowly travelled across the Earth over hundreds of millions of years. Their paths were not straight, and their movements changed direction many times because of the changing forces acting on the tectonic plates. As continents moved closer together, oceans between them became narrower. Some ocean floors were pushed beneath nearby continents through a process called subduction. During subduction, the heavier oceanic plate sank beneath another plate and moved deeper into the mantle. Over time, much of the ocean floor disappeared into the Earth. As the ocean closed, the continents on either side eventually met. When continents collided, neither continent easily sank beneath the other, because continental crust is lighter than oceanic crust. Instead, the edges of the continents were pushed upward, forming long chains of mountains. Some of the oldest mountain ranges that still exist today were created during the formation of Pangea. The rocks in these mountains preserve valuable information about the events that took place while the continents were joining together. The joining of continents happened step by step. Smaller landmasses first collided to form larger continents. These larger continents later joined with other landmasses. Each collision added more land to the growing supercontinent. This process continued over many millions of years until almost all of Earth's land became connected. One important stage involved the movement of a large southern landmass called Gondwana. Gondwana included areas that later became Africa, South America, Antarctica, Australia, the Indian subcontinent, and several nearby regions. Gondwana formed through earlier continental collisions. As time passed, Gondwana moved toward other continents. Another large northern landmass called Laurasia included what later became North America, Europe, and much of Asia. Like Gondwana, Laurasia formed through earlier movements of tectonic plates. As these two enormous landmasses slowly approached each other, the ocean between them became smaller. The closing of the ocean between Gondwana and Laurasia took millions of years. Oceanic crust continued to sink beneath nearby plates. Volcanoes formed in some regions where subduction was taking place. Earthquakes occurred as plates pushed against each other. Gradually, the remaining ocean disappeared, allowing the two giant land masses to meet. When Gondwana and Laurasia finally joined, they became part of one massive supercontinent known as Pangea. This event was completed around 335 million years ago. Pangea remained together for many millions of years before later beginning to break apart. Pangea stretched across a huge part of the Earth's surface. Almost all of the world's land was connected into one giant continent. Surrounding this enormous landmass was a single global ocean called Panthalassa. A smaller sea known as the Tethys Sea lay between different parts of Pangea and influenced the movement of water and the climate in nearby regions. The formation of Pangea changed many parts of the Earth's environment. As continents came together, coastlines changed. Ocean currents followed different paths because the arrangement of land and water had become very different. These changes affected temperatures, rainfall, and wind patterns across the planet. The center of Pangea lay far from the surrounding ocean. Because of this, many inland areas received less moisture than coastal regions. Some parts of this supercontinent became dry and experienced long periods with little rainfall. Large deserts developed in these regions, leaving behind layers of sand that later hardened into sandstone. These rocks still exist today and provide evidence of the dry conditions that existed during the time of Pangea. The formation of Pangea also influenced living things. Plants and animals that had once been separated by oceans could now spread across connected land. Many species expanded into new areas as suitable environments became available. At the same time, changes in climate caused some living things to adapt to new conditions while others disappeared from certain regions. The evidence for the formation of Pangea comes from many different scientific studies. One important source of evidence is the matching shapes of continental coastlines. Although modern coastlines have changed because of erosion and changing sea levels, the edges of the continental shelves fit together much more closely than the present coastlines alone. Another important source of evidence comes from fossils. Scientists have found identical fossils of certain plants and animals on continents that are now widely separated by oceans. These organisms could not have crossed such vast oceans. Their fossils suggest that the continents were once joined together as part of a single landmass. Rock formations also support the idea of Pangea. In many places, rocks of the same age and type appear on different continents. When the continents are placed back into their earlier positions, these rock layers line up very closely. Mountain ranges on separate continents also match each other in age, structure, and rock type, showing that they were once connected before later being separated by continental movement. Ice Age evidence provides another clue. Scientists have discovered marks left behind by ancient glaciers on continents that are now located in warm climates. These scratches and grooves in the rocks show the direction in which the glaciers once moved. When the continents are placed together in their earlier arrangement, the glacier patterns fit into a single system, providing further support for the existence of Pangea. The magnetic record preserved in rocks offers even more evidence. When melted rock cools and becomes solid, tiny magnetic minerals inside it line up with the Earth's magnetic field at that time. As continents move, these magnetic records remain locked inside the rocks. By studying them, scientists can determine how continents changed position over hundreds of millions of years. As the continents continued moving toward one another, the places where the plates met became some of the most active parts of the Earth. Huge amounts of pressure built up over long periods. The rocks at the edges of the continents did not remain flat. They were squeezed, folded, broken, and pushed upward. Thick layers of rock that had once rested beneath shallow seas slowly rose above sea level. New land appeared while older landscapes changed shape. Rivers found new paths, valleys formed, and broad highlands developed where the crust had become thicker. The pressure created during these continental collisions did not stop after the first contact between two land masses. The plates continued to push against each other for millions of years. Because the movement never stopped, the rocks continued changing. Deep underground, high temperatures and great pressure transformed many rocks into new forms. Limestone changed into marble, shale became slate, and other rocks were altered through the same process. These transformed rocks remain today and help geologists understand the conditions that existed while Pangea was taking shape. The oceans also changed during this period. As ocean basins became smaller, many areas that had once been covered by water were lifted above sea level. Marine sediments that had settled quietly on the sea floor were pushed upward onto land. Today, shells, coral remains, and other sea fossils are found high in mountain regions because those rocks were once part of ancient oceans that disappeared during the formation of Pangea. Some parts of the ocean floor did not simply disappear beneath nearby continents. Small pieces of oceanic crust were sometimes caught between two colliding continents instead of sinking completely into the mantle. These pieces remained trapped as the continents closed together. They contain rocks that are different from the surrounding continental rocks and provide another important record of the oceans that existed before Pangea formed. Volcanic activity was common in many places during this time. As oceanic plates descended into the mantle, water trapped inside the sinking rocks was released. This water lowered the melting point of nearby rocks, producing magma. The magma rose through cracks in the crust and reached the surface as lava. Layer after layer of volcanic material built up over time, creating volcanic mountain chains along some continental edges. Not every part of the growing supercontinent experienced the same conditions. Some regions remained close to the sea and received regular rainfall. Thick forests covered these areas, and many rivers carried fresh water across the land. Other regions lay much farther inland. Moist air from the oceans could not easily reach these places. As a result, they became much drier. Lakes appeared and disappeared with changing seasons, while strong winds carried sand across open landscapes. The movement of air across Pangea was different from the movement of air across the Earth today. Since the landmass was so large, weather systems travelled across great distances before reaching the middle of the continent. This influenced temperatures throughout the year. Some inland regions experienced very hot summers and much cooler winters because they were far from the moderating effect of the surrounding ocean. The rivers flowing across Pangea were also affected by the arrangement of the land. Some rivers stretched across great distances before reaching the sea. Others emptied into large inland basins where water collected for long periods. These rivers carried sand, mud, and small stones from mountains into lower areas. Over time, thick layers of sediment built up. These layers later hardened into sedimentary rocks that preserve a record of ancient environments. The coastlines of Pangea were constantly changing. Waves wore away exposed rock, while rivers carried new sediment toward the sea. In some places, shorelines slowly moved outward as sediments accumulated. In other places, rising seas covered low-lying land. These changes happened repeatedly over millions of years as both sea level and the shape of the land changed. The Earth's interior continued supplying the energy that drove plate movement throughout this entire period. Heat rising from deep within the mantle did not remain in one place. It slowly shifted over time. As convection currents changed direction, the forces acting on tectonic plates also changed. This caused some plates to speed up slightly, others to slow down, and some to begin moving in new directions. Although the movement of each plate was extremely slow, the combined effect across the whole planet was enormous. A plate moving only a few centimeters each year could travel hundreds or even thousands of kilometers over many millions of years. This steady movement allowed continents that had once been separated by broad oceans to eventually become connected. Scientists continue studying minerals inside ancient rocks to learn more about the formation of Pangea. Some minerals contain tiny amounts of radioactive elements that decay at a steady rate. By measuring these elements and the materials produced during decay, geologists can estimate when the rocks formed or when they were changed by heat and pressure. This dating method has helped build a detailed timeline of the events that created the supercontinent. The study of ancient sediments has also revealed information about changing climates during the growth of Pangea. Mud deposited in quiet lakes, sand left behind by rivers, and dust carried by wind each form different types of rock. These rocks preserve clues about rainfall, temperature, water depth, and the kinds of plants that lived nearby. Together they allow scientists to rebuild the environments that existed while the continents were coming together. Coal deposits formed in several parts of the growing supercontinent. These deposits began as thick layers of plant material that accumulated in wet, swampy areas. As more sediments buried the plants, heat and pressure slowly transformed them into coal. These coal beds provide evidence that large forests covered some regions during the time when Pangea was forming. The distribution of plant fossils also helps scientists trace the movement of continents. Certain ancient plants grew across wide areas of the connected landmass. Their fossils are now found on continents separated by vast oceans. Their presence supports the idea that these lands were once joined together, before later drifting apart. Animal fossils tell a similar story. Some reptiles, amphibians, insects, and early land animals spread across connected regions because there were no oceans blocking their movement. Fossils of these animals appear in rocks of the same age on several modern continents. Their wide distribution reflects the connected nature of Pangea during that period. The formation of Pangea also affected life in the oceans. As continents came together, the shape and size of shallow seas changed. Some marine habitats disappeared as oceans closed. Others developed along new coastlines. Marine organisms adapted to these changing conditions over long periods, while some species disappeared from areas where suitable habitats no longer existed. The Earth's climate during the formation of Pangea did not remain constant. Ice sheets expanded during some periods and retreated during others. Warm intervals were followed by cooler ones. These climate shifts were influenced by changes in atmospheric gases, volcanic activity, ocean circulation, and the changing arrangement of continents. Because the positions of land and sea strongly influence global weather patterns, the gradual assembly of Pangea played an important role in shaping Earth's climate. Evidence from ancient soils also provides information about the environments that existed during this time. Different soil types form under different conditions of rainfall and temperature. Fossil soils preserved within rock layers allow scientists to identify whether an area was once wet, dry, warm, or cool while Pangea was developing. Even after Pangea had become fully assembled, tectonic plates did not stop moving. the same forces that had brought the continents together remained active beneath the Earth's surface. Stress slowly accumulated within the supercontinent itself. Cracks eventually began forming in the crust as new plate movements developed. These cracks marked the beginning of another stage in Earth's history that would later lead to the separation of Pangea into the continents that exist today. Before those cracks became large enough to divide the landmass, the interior of Pangea experienced continued geological activity. Earthquakes occurred where old faults were reactivated. Magma sometimes rose through deep fractures, cooling underground to form large bodies of igneous rock. These features remain visible today in many regions that were once part of the ancient supercontinent. Modern technology has greatly improved the study of Pangea. Satellites measure the present movement of tectonic plates with remarkable accuracy. Global positioning system stations, placed on different continents, detect movements of only a few millimeters each year. These measurements confirm that plate motion is still taking place and provide a modern example of the same process that formed Pangea hundreds of millions of years ago. Researchers also use computer models to reconstruct the past positions of continents. By combining evidence from rocks, fossils, magnetic records, and plate movements, they can create detailed maps showing how the continents gradually moved together. These reconstructions continue to improve as new discoveries are made in geology, geophysics, and paleontology. Deep-sea drilling has added valuable information as well. Samples collected from the ocean floor reveal the age of oceanic crust. Scientists have found that oceanic crust becomes older as it extends away from mid-ocean ridges. This pattern demonstrates that new crust is continuously formed, while older crust is destroyed at subduction zones. Understanding this ongoing cycle has helped explain how ancient oceans disappeared during the assembly of Pangea. The rocks left behind from the formation of Pangea continue to influence the modern world. Many important mineral deposits formed during the intense heat, pressure, and volcanic activity associated with continental collisions. Valuable metals, industrial minerals, and building stones found today often owe their origin to the geological events that occurred while the supercontinent was taking shape. Earth during the age of Pangea was very different from the world people know today. Almost all of Earth's land was joined together into one enormous landmass called Pangea. This giant landmass stretched across a huge part of the planet and changed the way air moved, how rain fell, how rivers flowed, and how living things survived. The land was surrounded by a vast global ocean, while another large sea spread into parts of the supercontinent. Every part of the environment was connected in ways that shaped the daily conditions of the ancient world. The position of the land and sea affected temperatures, winds, rainfall, and the lives of plants and animals across many regions. Pangea existed during the late Paleozoic era and much of the Mesozoic era. It formed over millions of years as Earth's moving plates slowly pushed continents together. During this time, the surface of the planet looked very different from today. Places that are now separated by wide oceans were once joined together. Rocks, mountains, rivers, forests, deserts, and coastlines stretched across areas that later became different continents. Because the land was connected, many living things were able to spread across large distances without crossing oceans. The climate during the age of Pangea was not the same everywhere. Some places were very hot while others were cooler. Some regions received heavy rainfall for much of the year, while other places stayed dry for long periods. The size of the supercontinent played a major role in creating these different climates. Areas close to the coast often received more moisture because they were near the sea. Areas deep inside the continent were much farther from large bodies of water. As a result, many inland regions became dry because moist air lost much of its water before reaching them. The centre of Pangea contained some of the driest places on Earth. Rain rarely reached many of these areas. The ground often became dusty and hard. Rivers could shrink during dry times, leaving behind wide riverbeds filled with sand, stones and mud. Some lakes became smaller as water disappeared into the air through evaporation. Salt sometimes remained behind after the water was gone, forming thick layers on the ground. These layers remained buried for millions of years and can still be found in rocks today. Deserts covered large parts of the inland regions. Strong sunlight heated the ground during the day, causing very high temperatures. At night, the air often became much cooler because dry air did not hold heat well. These changes between day and night affected plants and animals living in these harsh environments. Only those able to survive with little water could continue living there. Sand dunes formed in many dry regions as strong winds carried loose sand across the land. The dunes slowly changed shape as winds blew from different directions during different times of the year. Some dunes became very large and stretched across wide areas. Layers of sand were buried over time and later turned into sandstone. Today, these ancient sandstone rocks provide evidence that deserts once covered parts of Pangea. The edges of the supercontinent experienced different weather. Coastal areas often received more rainfall because moist air moved inland from nearby seas and oceans. Rivers carried fresh water from mountains and hills toward the coast. Wetlands developed where rivers slowed down before reaching the sea. These places supported many kinds of plants and animals that depended on fresh water. The great ocean surrounding Pangea influenced weather patterns across the planet. Water warmed and cooled more slowly than land. Because of this, coastal regions often experienced smaller changes in temperature than in land areas. Winds moving from the ocean carried moisture that later fell as rain. The amount of rain depended on the direction of the winds, the shape of the land, and the height of nearby mountains. Large mountain ranges also affected the climate. As moist air moved toward mountains, it rose higher into the atmosphere. Rising air became cooler, allowing water droplets to form clouds. Rain often fell on one side of the mountains. By the time the air crossed over the mountain peaks, much of its moisture had already fallen. The air became drier as it moved into lower lands beyond the mountains, creating broad, dry regions. Many rivers flowed across Pangea. Some rivers began in high mountains where rain and melting snow supplied water. Others formed from seasonal rains. Rivers carried sand, mud, and small rocks across the land. These materials settled in river valleys and floodplains. During periods of heavy rain, rivers overflowed their banks and spread fresh layers of mud across nearby land. These deposits helped many plants grow. Floodplains supported thick plant life wherever enough water was available. Ferns, seed ferns, horsetails, conifers, cycads, and many other ancient plants covered parts of the landscape. Different plants grew in different climates. Wet regions supported thick forests, while dry regions had plants better suited to limited rainfall. Plant life changed gradually as climate conditions shifted over long periods. The seasons during the age of Pangea were influenced by Earth's movement around the Sun and the tilt of its axis, much as they are today. Different parts of the world experienced changing seasons each year. Some places had wet and dry seasons instead of large temperature changes. Other regions experienced warmer summers and cooler winters. Seasonal weather affected the growth of plants, the flow of rivers, and the movement of animals searching for food and water. The enormous size of Pangea made seasonal weather especially important. Inland areas often experienced stronger seasonal changes because they were far from the ocean. Summers could become extremely hot as the sun heated the land for many weeks. Winters could become much cooler after long periods without strong sunlight. These yearly changes affected the availability of water and food. In some regions, powerful seasonal storms developed when warm air met cooler air. Heavy rainfall sometimes caused rivers to flood across large areas. Floodwaters spread mud and nutrients across floodplains before slowly returning to river channels. During dry seasons, many rivers became smaller, exposing muddy banks where animals gathered to drink. The atmosphere during the age of Pangea also changed over time. The amount of oxygen and carbon dioxide in the air was not always the same throughout this long period. These changes affected temperatures, plant growth, and the lives of animals. Forests removed carbon dioxide from the atmosphere as they grew. Volcanoes released gases into the air, including carbon dioxide and water vapor. The balance between these natural processes changed over millions of years. Volcanic activity occurred in many parts of the ancient world. Molten rock sometimes reached the surface through cracks in Earth's crust. Lava spread across the land and later cooled into solid rock. Volcanoes also released ash, steam, and gases high into the atmosphere. Large eruptions could temporarily block some sunlight. With ash particles over longer periods, volcanic gases contributed to changes in Earth's climate. Earthquakes also occurred because Earth's plates continued moving even after Pangea formed. These movements created pressure within the crust. When the pressure became too great, rocks suddenly shifted, causing earthquakes. Some earthquakes changed the courses of rivers, lifted parts of the land, or created new cracks in the ground. Many mountain ranges were created as continents collided during the formation of Pangea. Rocks were pushed upward by enormous forces beneath Earth's surface. Over millions of years, wind, rain, rivers, and ice slowly wore these mountains down. The broken rocks were carried into valleys, rivers, lakes, and seas where they formed new layers of sediment. The coastlines of Pangea stretched for thousands of miles. Some coasts had sandy beaches while others had rocky cliffs. River mouths emptied into shallow seas, rich in sediments carried from inland regions. These shallow waters supported many forms of marine life, including shellfish, corals, fish, and other sea animals that depended on healthy coastal environments. Large inland seas also existed within parts of Pangea. These bodies of water influenced nearby climates by adding moisture to the air. They provided homes for many aquatic animals and plants. Water levels sometimes rose or fell as climate conditions changed over long periods. Sediments settled on the floors of these seas, preserving the remains of countless living organisms that later became fossils. The great global ocean surrounding Pangea contained powerful currents that moved water across vast distances. These currents carried heat from one region to another and influenced temperatures near coastlines. Changes in ocean circulation affected rainfall, storm patterns, and marine ecosystems. Scientists study ancient rocks and fossils to understand how these ocean currents behaved during different stages of Pangea's history. Many shallow coastal waters received sunlight that reached the seafloor. These bright waters supported rich plant growth, including algae that formed the base of many food chains. Small sea creatures fed on these plants, while larger animals hunted the smaller ones. The health of these marine environments depended on water temperature, sunlight, oxygen levels, and the movement of nutrients through the water. The skies above Pangea often reflected the changing weather. Clear days with bright sunshine were common in dry inland regions. Clouds gathered more often near coasts and mountains, where moist, air rose into the atmosphere. Thunderstorms developed during certain seasons, bringing lightning, heavy rain, and strong winds. These storms helped refill rivers and lakes after dry periods. The changing climate across the supercontinent influenced where different kinds of animals could live. Some thrived in warm forests, while others adapted to open plains, deserts, river valleys, or coastal wetlands. As weather patterns shifted over many thousands of years, animals sometimes moved into new areas where food and water remained available. The world before dinosaurs was already full of life, change, and many different kinds of animals. Earth had been changing for a very long time before the first dinosaur appeared. Mountains rose and wore away, seas spread across large parts of the land, and later pulled back. Volcanoes released hot rock and gases from deep inside the planet. Rivers carved valleys through the land. Winds carried dust from one place to another. Rain, heat, cold, and flowing water slowly shaped the surface of the planet. During this time, life continued to grow, spread, and change as different living things adapted to new conditions. The story of the world before dinosaurs began after Earth itself formed about 4,500,000,000 years ago. At first, the young planet was a very harsh place. The surface was extremely hot, and large pieces of rock from space often struck the planet. Volcanoes were active across many areas. There were no forests, no animals, and no people. The air was very different from the air that exists today. It contained large amounts of gases released by volcanoes. Over time, the surface slowly cooled. Water collected in low places and formed the first oceans. Clouds brought rain again and again over very long periods. As the planet cooled further, conditions became suitable for the earliest forms of life. The first living things were tiny organisms that lived in the oceans. They were far too small to be seen without powerful tools. These simple forms of life used different ways to survive. Some gained energy from chemicals found in their surroundings. Others later learned to use sunlight to make food. Tiny organisms that used sunlight slowly changed the atmosphere by releasing oxygen. This happened over an extremely long period. At first, oxygen was rare. As more of these tiny living things spread through the oceans, oxygen slowly increased. This change made it possible for many new kinds of life to appear in the future. As time passed, simple living things slowly gave rise to more complex forms of life. Some organisms developed many cells instead of only one. Different cells began performing different jobs inside the same body. This allowed living things to become larger and more organized. Many early animals lived only in the oceans because the land was still empty and difficult to survive on. The seas became home to many strange creatures with soft bodies and simple shapes. After many millions of years, animal life in the oceans expanded greatly. Many different groups appeared during a period when life became much more varied. Animals developed hard shells, protective coverings, and strong body parts. Some crawled across the sea floor, others swam through the water. Many had simple eyes that helped them detect light. Some had long bodies divided into many sections. Others had arms or legs that helped them move. This increase in the variety of life marked an important stage in Earth's history. Among the best-known animals from this ancient time were trilobites. These small sea animals had hard outer coverings that protected their bodies. They lived in oceans across much of the world. Their bodies were divided into several parts, and many species had large eyes that helped them find food and avoid danger. Trilobites became one of the most successful groups of early animals. Their remains are found in rocks on many continents because they lived for an extremely long time before finally disappearing much later. The oceans also became home to many early shellfish, sea worms, sponges, and animals related to modern starfish and sea lilies. Some attached themselves to the sea floor, while others moved slowly across it. Tiny floating organisms drifted through the water and became food for larger creatures. This created early food chains that supported many kinds of marine life. Some of the first animals with backbones also appeared in the oceans. These early fish were small and lacked jaws. Instead of biting food, they sucked in tiny particles or soft creatures. Their bodies were often protected by hard plates that acted as armor. These early fish represented an important step because they belonged to a group that would later produce many different animals, including amphibians, reptiles, birds, and mammals. Over time, fish continued to change. Some developed jaws that allowed them to catch larger prey. Teeth became more useful for holding and cutting food. Fins improved, making swimming faster and more controlled. Different kinds of fish spread through rivers, lakes, and oceans. Some became large hunters that fed on other animals. Others remained small and fed on tiny creatures or plants. One of the largest fish of this ancient world was Dunkleosteus. This powerful animal lived in the seas and reached a very large size. Instead of true teeth, it had sharp, bony plates that could cut through flesh and crush hard shells. It was one of the top hunters of its time. Although it lived many millions of years before dinosaurs appeared, it showed that large predators already existed in Earth's oceans. While life flourished in the water, the land remained mostly empty. Rocks, sand, rivers, and bare ground covered much of the surface. Gradually, simple plants began moving onto land. At first, these plants were small and stayed close to wet areas where water was easy to find. They had no flowers, fruits, or seeds like many modern plants. Instead, they reproduced using tiny spores that could be carried by the wind. As land plants spread, they slowly changed the environment. Their roots helped break apart rocks and create soil. Dead plant material mixed with broken rock to produce richer ground, where more plants could grow. Larger plants appeared over time. Some developed tall stems that lifted their leaves towards sunlight. Others formed wide patches that covered wet ground. Green landscapes slowly spread across parts of the continents. The growth of plants created new places where animals could live. Tiny insects and other small creatures began exploring the land. Early relatives of spiders, centipedes, and insects found food among the plants. Some fed on plant material, others hunted smaller animals. The movement of these creatures marked the beginning of animal life outside the oceans. Insects became one of the most successful groups of animals on Earth. Their small size allowed them to live in many places. Some had wings and became the first animals capable of powered flight. They flew through forests searching for food, mates, and safe places to lay eggs. Giant relatives of dragonflies appeared during some periods because the atmosphere contained higher levels of oxygen than today. Their wings stretched much farther than those of modern dragonflies. The first forests formed as plants became larger and more varied. Tall trees with simple leaves covered wide areas. Huge swamp forests developed in warm, wet regions. Dead plants often sank into muddy water where they decayed very slowly. Over enormous periods, thick layers of plant remains were buried under more sediments. Heat and pressure slowly changed these buried plants into coal. Many coal deposits mined today formed from these ancient forests that existed before dinosaurs. Life on land continued to grow more complex. Some fish developed stronger fins that helped them move through shallow water. During dry periods, these fish sometimes needed to cross muddy ground or move between pools of water. stronger fins and improved breathing abilities helped them survive. Over many generations, some fish developed limbs that allowed them to support their bodies on land. These animals became the first amphibians. They spent part of their lives in water and part on land. Many still laid their eggs in water because their young needed wet conditions to survive. Amphibians fed on insects, small fish, and other animals. They came in many sizes. Some remained small, while others became large hunters, living near rivers and swamps. As time continued, another important group of animals appeared. These were the earliest reptiles. Unlike amphibians, reptiles developed eggs protected by strong outer coverings. This allowed them to lay eggs on land without needing ponds or lakes for reproduction. Their skin also reduced water loss, making it easier to live in drier places. These changes allowed reptiles to spread across many different environments. The earliest reptiles were generally small. They hunted insects and other tiny animals. Over many millions of years, reptiles became more varied. Some remained small and quick. Others grew much larger. Different groups adapted to deserts, forests, rivers, and coastal areas. This wide variety of reptiles eventually led to many branches, including the ancestors of dinosaurs. The continents were not arranged as they are today. Earth's surface was constantly moving because of slow movements deep within the planet. Pieces of the outer crust drifted over vast stretches of time. Sometimes continents moved apart, at other times they collided. These movements created mountain ranges, opened new oceans, and closed older seas. During one important period before dinosaurs, nearly all of Earth's major land areas slowly came together into a single giant landmass known as Pangea. This enormous continent stretched across a large part of the planet. Vast deserts formed in some regions because areas far from the coast received little rainfall. Other regions contained forests, rivers, lakes, and swamps. Animals could travel across great distances without crossing large oceans because so much land was connected. The climate before dinosaurs was not always the same. Earth experienced warm periods as well as colder times. There were ages when ice covered large parts of the land. Huge glaciers slowly moved across the surface, carving valleys and carrying rocks over long distances. As climates changed, glaciers melted, sea levels rose, and new habitats appeared. Living things had to adjust again and again to changing conditions. The changing climate affected plants and animals in many ways. Some species spread into new regions. Others disappeared because they could not survive the new conditions. New species developed as populations adapted to different environments. These gradual changes shaped the history of life for millions of years before dinosaurs appeared. Before dinosaurs, many unusual reptiles ruled the land. Some walked on 4 legs, while others moved on 2 legs for short distances. Certain species had large sail-like structures rising from their backs. One famous example was Dimetrodon. Although many people mistakenly believe it was a dinosaur, it lived many millions of years before the first true dinosaurs appeared. It belonged to a different group of animals that was more closely related to the ancestors of mammals than to dinosaurs. Dimetrodon hunted other animals living around rivers and wetlands. Its strong jaws contained large teeth that allowed it to catch prey. The tall structure on its back was formed by long bones connected by skin. Scientists continue studying the exact purpose of this feature. It may have helped control body temperature or served another important role. Another important group before dinosaurs was the synapsids. These animals included many forms, ranging from small insect eaters to large meat eaters and plant eaters. Synapsids became very successful across many environments. Over long periods, some branches slowly developed features that would later be seen in mammals. These changes included differences in their teeth, jaws, and body structure. Some synapsids developed different kinds of teeth for different jobs. Front teeth could grip food, while larger teeth farther back crushed or sliced it. This allowed them to eat a wider variety of foods. Their jaws became stronger and their chewing improved. These developments would later become important in mammal evolution. The land before dinosaurs also supported many plant-eating reptiles. These animals fed on leaves, stems, roots, and other plant parts. Some traveled alone, while others may have lived in groups. Their feeding helped shape plant communities by removing certain plants and spreading spores or seeds. Predators hunted these plant eaters. Strong jaws, sharp teeth, quick movement, and good senses helped hunters find food. At the same time, prey animals developed ways to stay alive. Some relied on speed. Others depended on protective body coverings or large size. Many used hiding places among plants or near water. The oceans before dinosaurs remained full of life. Coral-like organisms built underwater structures where many animals found shelter. Shellfish filtered tiny food particles from the water. Squid-like animals with hard shells drifted or swam through ancient seas. Fish continued becoming more varied. Some occupied shallow coastal waters, while others lived in deeper oceans. Small organisms remained the foundation of ocean life. Tiny plants floating near the surface used sunlight to make food. Tiny animals fed on these microscopic plants. Fish and other sea creatures fed on the smaller animals. Larger hunters then fed on the fish. This network supported many forms of marine life. Volcanic activity continued shaping the world before dinosaurs. Volcanoes sometimes erupted gently, allowing lava to flow across the land. Other eruptions were much more violent, sending ash high into the atmosphere. Ash settled over forests, rivers, and lakes. Some eruptions changed local environments by covering the ground with fresh rock. Plants later returned as new soil slowly formed. Earthquakes also occurred as the planet's crust continued moving. Some earthquakes changed river paths or caused landslides. Others opened cracks in the ground. These natural events were part of Earth's constant activity and affected both landscapes and living things. Rivers before dinosaurs carried sand, mud, and gravel from mountains to lower areas. Floods spread fresh layers of sediment across plains. Lakes formed where water collected. Some lakes lasted for very long periods, while others dried up during changing climates. These rivers and lakes became homes for fish, amphibians, insects, and many other creatures. Wind shaped dry regions by moving sand into dunes. Rain slowly wore down mountains and carried broken rock into valleys. Coastal waves reshaped shorelines where land met the sea. These natural forces constantly changed Earth's surface, even though many changes happened so slowly that they would not have been noticed during a single lifetime. Many fossils from the time before dinosaurs have been preserved because animals and plants were buried quickly after death. Mud, sand, volcanic ash, or fine sediments covered their remains before scavengers and weather destroyed them. Minerals slowly replaced the original material, creating fossils that remained hidden inside rocks for millions of years. Scientists study these fossils to understand the ancient world. Bones reveal the size and shape of animals. Teeth show what they likely ate. Footprints preserved in mud reveal how they moved. Burrows indicate where animals lived. Fossilized leaves show what kinds of plants grew in different places. Pollen grains preserved in rocks provide clues about ancient forests and climates. Rock layers also help scientists understand the order of events before dinosaurs. Older layers usually lie beneath younger ones unless later geological events changed their position. By studying these layers together with fossils, researchers can build a detailed history of Earth's past. Chemical studies of ancient rocks provide information about the atmosphere, oceans, and climate. Tiny changes in the amounts of certain elements help scientists estimate temperatures, rainfall, and ocean conditions from the distant past. This information is combined with fossil evidence to create a clearer picture of life before dinosaurs. One of the most important events before dinosaurs was the greatest known mass extinction in Earth's history. It happened about 252 million years ago, near the end of the Permian period. During this event, most marine species and many land species disappeared. The exact causes are still being studied, but massive volcanic eruptions, changes in climate, falling oxygen levels, ocean changes, and other environmental problems likely work together over time. Life across the planet was affected on a very large scale. The extinction changed forests, rivers, oceans, and food chains. Many groups that had once been common vanished completely. Others survived only in small numbers. The planet entered a difficult period as ecosystems slowly recovered. Empty habitats gradually became available for surviving species and for new groups that later evolved. After this extinction, the Triassic period began. During the early part of this period, Earth looked very different from the rich ecosystems that had existed before. Many areas had fewer species than in earlier times. Plants slowly spread again across damaged landscapes. Animal populations increased little by little. New reptiles became more common as they adapted to the changing world. Among these reptiles were the earliest relatives of dinosaurs. At first, they were not the largest or most common animals. Other reptile groups still dominated many environments. Early dinosaur ancestors were generally small, active animals that lived alongside many other reptiles rather than ruling the land. The world that greeted these early dinosaur ancestors had already experienced countless changes across oceans, forests, deserts, mountains, rivers, and plains. The plants they ate or lived among had deep histories, stretching back through many earlier ages. The animals they encountered were descendants of lineages that had survived repeated environmental changes and extinction events. The rocks beneath their feet contained the remains of forests, fish, insects, amphibians, reptiles, and countless other living things that had lived and died across an immense span of Earth's history. The first dinosaurs appeared during the Triassic period, a time when Earth looked very different from the world we know today. They evolved around 230 million years ago. This was a period of great change in the history of life. The continents were joined together into one giant landmass called Pangea. Huge deserts stretched across many regions, while rivers, lakes, forests, and grassy areas were found in other places. The climate was often hot and many places experienced long dry seasons, followed by periods of heavy rain. These changing conditions shaped the lives of every living thing, including the small reptiles that eventually gave rise to the first dinosaurs. The world during the early part of the Triassic period was still recovering from the greatest mass extinction ever known. This terrible event had happened at the end of the Permian period and had wiped out most of the plants and animals living on Earth. Many habitats became empty because so many species disappeared. As life slowly returned, new kinds of plants and animals spread across the land and seas. The empty environments gave surviving groups the chance to grow, change, and develop into new forms. Among these changing reptiles were the distant ancestors of dinosaurs. The earliest dinosaurs did not suddenly appear. Their arrival was the result of a long process of evolution that lasted millions of years. Small changes happened in each generation. Some animals developed bodies that helped them move more easily, find food more successfully, or escape danger more quickly. Those useful features were passed on to their young. Over many generations, these changes became greater until entirely new kinds of animals appeared. This slow process eventually produced the first true dinosaurs. Scientists believe that dinosaurs evolved from a group of reptiles known as archosaurs. Archosaurs were already successful animals during the Triassic period. This group also included the ancestors of crocodiles and flying reptiles, called pterosaurs. Although these animals shared common ancestors, each group followed its own path over time. Dinosaurs became one branch of the archosaur family tree, and gradually developed features that separated them from their close relatives. One important feature of the earliest dinosaurs was the position of their legs. Unlike many older reptiles whose legs stretched out to the sides, dinosaurs had legs that stood directly beneath their bodies. This body structure allowed them to walk, run, and balance more efficiently. Their movement used less energy and made it easier to travel longer distances. This upright posture became one of the most important features that identified dinosaurs throughout their long history. The earliest dinosaurs were much smaller than the giant animals that later lived during the Jurassic and Cretaceous periods. Many were only about the size of a chicken, a turkey, or a medium-sized dog. Some stood only about 1 meter tall. Others were a little larger, but still far smaller than the enormous plant-eating and meat-eating dinosaurs that would appear many millions of years later. Their small size probably helped them move quickly through forests, riverbanks, and open land while searching for food and avoiding larger predators. The first dinosaurs likely lived alongside many other reptiles that were not dinosaurs. During the Triassic period, the land was filled with different kinds of reptiles. Some were large hunters with powerful jaws, others fed on plants or insects. Many strange animals walked across the land, and several groups competed for food and living space. Dinosaurs were only one small part of this rich collection of life during their early history. The oldest dinosaur fossils discovered so far come mainly from areas that are now part of South America. These ancient rocks have provided important clues about where dinosaurs first evolved. One of the most famous places is northwestern Argentina. Rocks found there have preserved the remains of several early dinosaur species. These fossils show that dinosaurs were already living in this region around 230 million years ago. Southern Brazil has also produced important dinosaur fossils from the same general period. Fossils found there include some of the oldest known dinosaurs and their close relatives. The rocks of Brazil help scientists understand how these early animals lived, moved, and changed over time. The discoveries from both Argentina and Brazil suggest that the southern part of Pangea was one of the earliest homes of dinosaurs. At the time when these animals lived, South America was not separated from Africa, Antarctica, Australia, or India. All these lands were connected as part of the giant southern region of Pangea. Animals could move across large areas without crossing wide oceans. This allowed early dinosaurs to spread into new environments as they searched for food, mates, and safe places to live. One of the earliest known dinosaurs is Eoraptor. Its name means dawn thief, reflecting its place among the earliest dinosaurs discovered by scientists. Eoraptor lived around 230 million years ago in what is now Argentina. It was a small animal measuring about 1 meter in length. It walked on 2 legs and had sharp claws and teeth. Scientists believe it probably ate small animals such as insects, tiny reptiles and other creatures, although it may also have eaten plants when food was available. Another early dinosaur was Herrerasaurus. This dinosaur also lived in what is now Argentina during the same period. Herrerasaurus was much larger than Eoraptor, reaching several meters in length. It had strong legs, long arms with sharp claws, and a mouth filled with sharp teeth. It was probably an active hunter that fed on smaller animals living around rivers and forests. Its fossils have provided important information about the early stages of dinosaur evolution. Styracosaurus is another early dinosaur found in Brazil. It lived during the late Triassic period and shared many features with other early meat-eating dinosaurs. It had a light body, long tail, and powerful legs that helped it move quickly. Fossils of Styracosaurus help scientists understand how the earliest dinosaurs spread across different parts of southern Pangea. Some fossils discovered in Zimbabwe suggest that dinosaurs may also have lived in parts of Africa during the same period. These discoveries support the idea that early dinosaurs spread across connected land areas while Pangea remained united. Fossils from India also show that dinosaurs had reached different regions of the supercontinent before it began to break apart. Scientists continue searching for even older dinosaur fossils. Every new discovery has the potential to change what is known about dinosaur origins. Fossils are often incomplete because bones may be broken, buried deeply underground, or destroyed over millions of years by erosion, earthquakes, heat, and pressure. New discoveries sometimes reveal species that were previously unknown, helping scientists build a clearer picture of early dinosaur history. Finding fossils from the Triassic period is often difficult, because rocks from this age are not exposed everywhere. In many places they remain buried beneath younger rocks. Some fossil sites are located in dry deserts where erosion has uncovered ancient rock layers. Others are found in mountains where the movement of Earth's crust has lifted old rocks to the surface. Paleontologists spend many years searching these areas for bones, footprints, and other signs of ancient life. The earliest dinosaurs lived in environments that included rivers, floodplains, forests, open woodlands, and dry regions. Some areas received heavy seasonal rains that caused rivers to overflow. Floodwaters spread mud across the land, burying dead animals beneath layers of sediment. These sediments sometimes protected bones from decay, allowing fossils to form over millions of years. Plants during the Triassic period were different from those found today. Flowering plants had not yet evolved. Instead, the landscape included many kinds of ferns, horsetails, seed ferns, cycads, conifers, and ginkgo-like trees. These plants provided food for plant-eating animals and shelter for smaller creatures. Early dinosaurs moved through these ancient forests while searching for food or escaping predators. The air during the Triassic period contained oxygen, carbon dioxide, and other gases, but the atmosphere differed somewhat from today's conditions. Temperatures were generally warmer than those experienced in many parts of the modern world. There were no polar ice sheets like those covering Antarctica today. Seasonal weather patterns affected water supplies and plant growth across different regions. The first dinosaurs probably hatched from eggs buried in nests made on the ground. Although direct evidence from the earliest dinosaurs is limited, later dinosaur fossils show that egg-laying was common throughout the group. Young dinosaurs likely grew quickly after hatching. Their parents may have protected them for a period of time, although scientists are still studying how much care the earliest dinosaurs provided. Early dinosaur bones show that these animals were active and fast-moving. Their skeletons were lighter than those of many older reptiles. Hollow spaces inside some bones helped reduce body weight without making the bones weak. This body structure supported efficient movement across different types of land. The tails of early dinosaurs helped maintain balance while running or changing direction. Their heads remained steady as they moved, allowing them to watch for food or danger. Their arms varied depending on the species. Some had longer arms with grasping hands, while others had shorter forelimbs. Sharp claws helped many early dinosaurs catch prey or handle food. The skulls of the first dinosaurs also show important changes. Openings in the skull reduced weight while providing space for strong jaw muscles. Their teeth differed depending on diet. Meat-eating species had pointed, curved teeth suited for cutting flesh. Plant-eating species developed teeth better suited for cutting leaves and soft plant material. Some early dinosaurs may have eaten both plants and animals, depending on what food was available. Scientists divide dinosaurs into two major groups based on the shape of their hips. These groups are known as Saurischeans and Ornithischians. The earliest dinosaurs were mainly members of the Saurischean group. This group later produced both giant, long-necked plant-eaters and fierce, meat-eating predators. Ornithischian dinosaurs appeared later and eventually became a very successful group that included many plant-eating species. The process of identifying the earliest dinosaurs is not always simple. Some reptiles living during the Triassic period had features that closely resembled dinosaurs. Scientists carefully examine fossil bones to determine whether an animal was truly a dinosaur or belonged to another closely related group. Even small differences in the hip bones, ankle bones, or skull can provide important clues. Modern technology has greatly improved the study of early dinosaur fossils. High-resolution scans allow scientists to examine bones without damaging them. Powerful computers create detailed three-dimensional models of skeletons. These models help researchers study movement, growth, and body structure in ways that were not possible in the past. Microscopic examination of fossil bones has revealed that many early dinosaurs grew rapidly. Growth rings inside bones provide information similar to the rings found in tree trunks. By studying these patterns, scientists estimate how quickly dinosaurs matured and how long they lived. Some early dinosaurs reached adulthood within only a few years. The first dinosaurs shared the land with many insects, including early beetles, dragonflies, cockroaches, and other flying insects. These insects formed an important part of the food chain. Small meat-eating dinosaurs may have hunted large insects as part of their diet. Insects also played important roles in breaking down dead plants and animals. Small mammals had also begun to appear during the Triassic period. These early mammals were tiny creatures that mostly remained hidden. From larger reptiles, they were active during different times of the day and fed on insects and other small food sources. They lived alongside the first dinosaurs but remained much smaller and less common. Amphibians continued living in rivers, lakes, and wetlands. Some species grew to impressive sizes and hunted fish or other animals. Fish filled rivers and freshwater lakes, while marine reptiles ruled many parts of the oceans. Dinosaurs remained land animals and did not live permanently in the sea or fly through the air. The breakup of Pangea had not yet begun when the first dinosaurs evolved. Because the continents remained connected, animals could spread across huge distances over many generations. As dinosaurs slowly expanded into new regions, isolated populations developed their own features. This process eventually produced many different species living across the world. Climate changes during the late Triassic period affected plant growth and water supplies. Some regions became wetter, while others remained dry. These changing conditions influenced where animals could survive. Dinosaurs that adapted successfully spread into new environments, and gradually increased in number. For many millions of years after their first appearance, dinosaurs remained relatively uncommon. They did not immediately become the dominant land animals. Other reptile groups continued to occupy many habitats. Dinosaurs slowly increased their numbers while developing new forms and lifestyles. Their rise happened gradually rather than all at once. A major extinction event near the end of the Triassic period changed life on Earth once again. Many groups of reptiles disappeared during this event. Dinosaurs survived, while many of their competitors did not. After this extinction, dinosaurs expanded into newly available habitats and became the leading land animals during the Jurassic period. The study of early dinosaur footprints has added important information to what bones alone can provide. Fossil footprints preserved in ancient mud show how dinosaurs walked, ran, and traveled together. Some trackways suggest that certain species moved in small groups, while others appear to have traveled alone. Footprints also reveal the size of animals that may never have been found as complete skeletons. The colors of the earliest dinosaurs remain uncertain because soft tissues rarely become fossils. Scientists sometimes study fossilized feathers from later dinosaurs and microscopic structures preserved in exceptional fossils to estimate possible colors. But very little direct evidence exists for the first dinosaurs. They may have displayed a range of colors that helped them recognize one another, hide from predators, or attract mates. Although feathers are often linked with later dinosaurs, scientists continue studying whether some of the earliest dinosaurs possessed simple feather-like body coverings. Evidence from close relatives and later species suggests that simple body coverings may have appeared earlier than once believed. Research in this area continues as new fossils are discovered. Breathing in early dinosaurs was probably efficient because their skeletons show features linked with advanced breathing systems. Some later dinosaurs had air sacs connected to their lungs, and scientists believe the earliest members of the group may already have possessed the beginnings of this system. Efficient breathing would have supported active movement and rapid growth. The brains of the earliest dinosaurs were not especially large, but they were well suited to their needs. Their senses helped them survive in challenging environments. Good eyesight allowed hunters to detect movement. A strong sense of smell helped locate food, recognize members of the same species, and detect danger. Balance was supported by structures inside the skull that helped coordinate movement. Every fossil discovery adds another piece to the story of dinosaur origins. Some fossils consist of complete skeletons, while others include only a few bones, a single tooth, or footprints preserved in stone. Even these small discoveries can answer important questions about where dinosaurs lived, how they moved, and how they changed over time. Scientists from many countries work together to study the earliest dinosaurs. Paleontologists collect fossils in the field, prepare them carefully in laboratories, describe new species, and compare discoveries with fossils found in other parts of the world. Geologists study the rock layers where fossils are found, helping determine their age and the ancient environments in which the animals lived. Biologists examine living animals such as birds and crocodiles to better understand the features inherited from ancient archosaurs. The first dinosaurs represent the beginning of one of the longest-lasting groups of land animals in Earth's history. From their small beginnings during the Triassic period, they slowly spread across the connected continents of Pangea. Their early evolution laid the foundation for the many different dinosaur groups that later appeared across forests, plains, river valleys, deserts, and other environments throughout the Jurassic and Cretaceous periods. Since there were no great oceans cutting the land into separate continents, dinosaurs did not need to cross large stretches of water to reach new places. They could slowly move across connected land over many generations. Individual dinosaurs did not travel across the whole of Pangea during their own lifetimes. Instead, each new generation spread a little farther than the one before it. As families searched for food, water, nesting places, and safer living areas, they gradually reached regions that had never been occupied by their ancestors. Food was one of the main reasons dinosaurs moved into new areas. Plant-eating dinosaurs depended on the growth of ferns, seed ferns, cycads, conifers, horsetails, and many other ancient plants. If food became scarce in one region because of changing weather, drought, or heavy feeding by large groups of animals, some dinosaurs would slowly move toward places where fresh plants were growing. Meat-eating dinosaurs followed the animals they hunted. If large plant-eating dinosaurs entered a new area, the predators that depended on them often spread in the same direction. This steady movement helped many different dinosaur species expand across large parts of Pangea. Water also played a very important role in dinosaur movement. Rivers provided fresh water for drinking and supported many kinds of plant life. Lakes attracted animals from many directions. River valleys often had richer soil than the dry lands farther away. Plants grew more easily there, bringing plant-eaters and the predators that hunted them. As rivers changed their paths over time, animals also changed the routes they followed. These natural pathways connected many different regions of the giant continent. Seasonal weather encouraged movement as well. Some areas received more rainfall during certain parts of the year, while others became extremely dry. Animals living in these regions had to respond to changing conditions. They searched for fresh plants, cleaner water, and better shelter. Although scientists continue to study whether some dinosaurs made regular, seasonal journeys, there is good evidence that many species slowly shifted their living areas as environmental conditions changed over long periods. The connected land of Pangea allowed forests to spread across wide regions. Many forests were filled with tall conifer trees that stayed green throughout the year. Other places had thick growths of ferns and seed plants. These forests gave shelter from harsh sunlight and strong winds. They also provided food for many animals. Plant-eating dinosaurs living in one forest could slowly move into neighboring forests without meeting major natural barriers. As these forests stretched across large areas, they formed natural routes that helped animals spread. Open plains also supported dinosaur movement. These wide spaces contained grasses only much later in Earth's history, but they held many low-growing plants, ferns, shrubs, and scattered trees. Large plant-eaters could feed while continuing to move across these open lands. Predators could follow the same routes in search of prey. Since there were few natural barriers in many of these plains, animal populations gradually expanded farther across the continent. Mountain ranges did exist on Pangea, and they influenced where animals could travel. Some mountains blocked easy movement and separated different environments. However, many mountain regions contained lower passes that animals could cross. Valleys between mountains also served as natural travel routes. Over thousands of generations, dinosaur populations slowly reached new regions beyond these higher lands. Deserts covered large parts of central Pangea. These dry regions could be difficult places for many animals. Water was limited, temperatures often became very high during the day, and food could be scarce. Even so, deserts were not impossible to cross. Rivers flowing through dry lands created greener areas where animals could stop to drink and feed. Some dinosaurs were able to live near desert edges, while others crossed these dry regions over long periods as they searched for better habitats. Coastal regions offered another path for movement. The long coastlines of Pangea supported many different plants and animals. Rivers flowing into the sea created fertile areas where vegetation grew well. Wetlands, marshes and floodplains formed rich environments filled with food. Dinosaurs living near these coastal areas could slowly spread along the shoreline for great distances, because the land remained connected. As dinosaurs expanded into new places, they encountered many other kinds of animals already living there. Ancient crocodile relatives, early mammals, amphibians, large insects, flying reptiles, and many reptiles shared these environments. Each group depended on available food and living space. Dinosaurs became successful, partly because many of them adapted well to changing conditions. Different species developed different diets, body sizes, and behaviors that allowed them to live in many kinds of habitats. Reproduction also helped dinosaur populations spread across Pangea. Dinosaurs laid eggs, and many species produced several young during each breeding season. As young dinosaurs grew older, they needed their own space and food. Some moved away from the places where they hatched. Over many generations, this gradual expansion allowed populations to occupy larger regions of the connected continent. Climate changes happened many times during the age of Pangea. Rainfall increased in some regions and decreased in others. Rivers shifted course. Lakes grew larger or dried up. Forests expanded into some places while shrinking in others. These environmental changes encouraged animals to move in search of better conditions. Since the land remained connected, dinosaurs could continue spreading into areas where food and water were more available. Volcanic activity also affected parts of Pangea. Volcanoes released lava, ash, gases and heat into the environment. Some nearby areas became dangerous for animals. Plants could be destroyed, rivers could change direction, and ash could cover the land. Dinosaurs living near active volcanic regions sometimes had to leave and settle elsewhere. Over time, plants often returned to these areas, allowing animals to move back again. Different dinosaur groups traveled in different ways, depending on their size and lifestyle. Small dinosaurs could move quickly through forests and open land. Medium-sized dinosaurs often covered large areas while searching for food. Giant plant eaters moved more slowly but steadily across wide landscapes. Predators followed the movements of prey animals, staying close to reliable food sources. These different movement patterns helped many dinosaur species occupy large parts of Pangea. Some dinosaur species became widespread because they were able to survive in many environments. They could live in forests, river valleys, floodplains, and open areas. Their flexible diets or feeding habits allowed them to adjust to changing food supplies. Other species had more limited needs and remained within smaller regions where conditions matched their requirements. Even so, the connected land still made movement easier whenever suitable habitats stretched into neighboring areas. Scientists learn about dinosaur movement by studying fossils found across different continents today. Since Pangea later broke apart into separate continents, fossils of related dinosaurs are now discovered in places that are thousands of kilometers apart. Similar dinosaur bones have been found in South America, Africa, North America, Europe, Asia, Antarctica, and Australia. These discoveries show that many dinosaur groups once lived across connected regions before the continents separated. Footprints provide another important source of information. Dinosaur tracks preserved in ancient mud reveal that these animals walked across riverbanks, floodplains, lake shores, and coastal areas. Some trackways continue for long distances, showing steady movement across the landscape. Large numbers of footprints found together sometimes suggest that groups of dinosaurs traveled through the same area at about the same time. Fossil eggs and nesting sites also help scientists understand dinosaur distribution. Similar nesting behaviors have been discovered in different parts of the ancient world. These findings suggest that related dinosaur groups spread across large regions while continuing similar ways of raising their young. Suitable nesting grounds often developed near rivers, lakes, or open plains where food was available for growing families. The movement of Earth's tectonic plates slowly changed the shape of Pangea. Cracks began forming across the supercontinent during the Jurassic period. These cracks widened over millions of years. New oceans gradually formed between the separating landmasses. Areas that had once been connected by dry land slowly became isolated from one another. Animal populations that had once mixed freely became separated. As continents drifted apart, dinosaur populations living on different landmasses began following separate paths of development. Species living in one region no longer met those living in another because oceans blocked their movement. New environments also developed as climates changed on the separating continents. These conditions encouraged the appearance of different dinosaur species in different regions. During the earlier stages of Pangea, however, movement remained much easier than it became later. A dinosaur population living in what is now South America could gradually expand into land that is now Africa, because those regions were connected. From there, later generations could continue spreading into areas that would become Europe or Asia if suitable environments existed along the way. Similar pathways connected regions that later became North America. These connected routes gave many species opportunities to occupy enormous areas across the ancient world. The spread of dinosaurs did not happen all at once. It was a slow process that took millions of years. Small groups entered new territories, settled there, raised young, and expanded farther over many generations. Some populations disappeared because of disease, drought, floods, volcanic activity, or competition for food. Others survived and continued spreading. This constant movement changed where different dinosaur groups lived throughout the age of Pangea. Many young dinosaurs probably learned travel routes by following older members of their groups. Adults knew where rivers flowed, where plants grew well, and where dangers were greatest. Staying together increased the chances of finding food and avoiding predators. Family groups may have gradually explored nearby regions before settling in new locations. Floodplains were especially valuable for many dinosaur species. Seasonal flooding deposited fresh soil that supported healthy plant growth. These fertile lands attracted plant eaters throughout the year whenever enough water remained available. Meat eaters also visited these regions because prey animals gathered there. The connected floodplain systems across Pangea allowed animal populations to spread naturally as they followed food and water. Large river systems linked distant parts of the continent. Some rivers flowed for very long distances before reaching the sea. Their banks supported forests and wetlands filled with life. Dinosaurs moving along these waterways could gradually reach entirely new regions without crossing major barriers. River crossings were easier during dry seasons when water levels fell, while higher water during rainy seasons sometimes changed travel routes. Changing sea levels also affected movement across Pangea. When sea levels dropped, more coastal land became available for plants and animals. New habitats appeared along the shoreline, giving dinosaurs additional living space. When sea levels rose, some low-lying areas became flooded, forcing animals to move inland. These natural changes influenced where populations settled over time. Wind patterns affected rainfall across the giant continent. Some regions became wetter, while others stayed dry for long periods. Areas receiving regular rain supported thick plant growth, attracting many plant eaters. dry regions supported fewer animals. As climate patterns slowly shifted, dinosaurs adjusted by expanding into newly favorable areas while leaving regions that could no longer support large populations. Disease may also have influenced dinosaur movement. Illness spreading through crowded populations could encourage survivors to move away into less crowded regions. Although direct fossil evidence for dinosaur diseases is limited, scientists know that diseases affect modern animal populations and likely influenced ancient ecosystems as well. Natural disasters such as earthquakes, floods, storms, droughts, and volcanic eruptions sometimes forced entire populations to leave familiar habitats. Since connected land stretched across much of the world, displaced animals often found new places where conditions were better. Over many generations, these movements contributed to the broad distribution of dinosaur species across Pangea. Different body sizes influenced how dinosaurs spread. Smaller dinosaurs needed less food each day and could survive in places where resources were limited. Larger dinosaurs required greater amounts of vegetation or prey, leading them to move more often as food supplies changed. These different needs produced different patterns of expansion across the continent. Young forests that grew after fires or floods produced fresh plant growth. Plant-eating dinosaurs often fed in these recovering areas because young plants were easier to eat. Predators followed these feeding grounds. Natural cycles of destruction and regrowth therefore encouraged continual movement across the landscape. The connected nature of Pangea also increased opportunities for genes to spread between populations. When animals from neighboring regions met and reproduced, they mixed genetic traits across wide areas. This helped maintain healthy populations over large regions, while allowing local differences to appear as groups settled in different environments. Scientists continue discovering new fossils that improve understanding of dinosaur movement across Pangea. Every new skeleton, footprint, egg, tooth, or fossilized bone adds information about where different species lived and how far they spread. Careful study of rock layers, ancient climates, fossil pollen, plant remains, and sediment helps researchers rebuild the environments these animals once occupied. The story of dinosaurs spread across Pangea is closely connected to the geography of the ancient Earth. One enormous landmass allowed gradual movement across regions that later became separate continents. Rivers, forests, plains, wetlands, floodplains, coastlines, valleys, and mountain passes created natural pathways that many species followed over millions of years. Food, water, climate, reproduction, changing environments, and the search for safe living places all encouraged dinosaurs to expand into new regions, while the continents remained joined together. As long as these land connections existed, many dinosaur groups had opportunities to occupy vast areas of the ancient world, leaving behind fossils that are now found across continents that became separated only after Pangea slowly broke apart. Dinosaurs lived in many different parts of the world for a very long time, and every day they needed food to stay alive. Just like all other living animals, they had to eat enough to grow, move, heal from injuries, produce young, and survive changes in their surroundings. The kind of food a dinosaur ate depended on the shape of its body, the size of its teeth, the length of its neck, the way it moved, and the place where it lived. Some dinosaurs spent most of their time eating plants, while others searched for animals to eat. Every meal helped them gain the energy needed for walking, running, digging, nesting, and carrying out their daily activities. Food was one of the most important parts of dinosaur life because without it, they could not survive. The land where dinosaurs lived was filled with many kinds of plants. Different areas had different plant life depending on the weather, the amount of rain, the soil, and the season. Some places had thick forests with tall trees that stayed green for much of the year. Other places had open areas where lower plants spread across the ground. Rivers, lakes, and wetlands supported many kinds of plant life that provided food for large numbers of animals. Dinosaurs that ate plants often stayed close to places where food was easy to find. If the food became harder to reach because of dry weather or changes in the land, they often moved to places with better growing conditions. Plant-eating dinosaurs ate many kinds of leaves. Leaves were one of the most common foods because they were found on trees, bushes, and many other plants. Some dinosaurs stretched their long necks high into the air to reach leaves, growing near the tops of tall trees. Others stayed close to the ground and fed on leaves growing on smaller plants. The shape of a dinosaur's neck often affected which leaves it could reach. Dinosaurs with long necks could eat from a wide area without moving their whole bodies, while shorter animals had to walk from one plant to another as they searched for food. Many plant-eating dinosaurs also ate soft shoots. New shoots were fresh parts of growing plants that were easier to bite and digest than older parts. These young shoots often contained water and nutrients that helped support healthy growth. During times when plants were growing quickly, many dinosaurs likely searched for these fresh parts because they were easier to eat and provided valuable nourishment. Ferns formed another important part of the diet of many plant-eating dinosaurs. Ferns grew across large areas and spread well in places with enough moisture. They did not produce flowers like many modern plants, yet they covered wide stretches of land and provided food for many animals. Dinosaurs feeding on ferns often lowered their heads toward the ground and slowly gathered large amounts with each bite. Since ferns were common in many places, they helped support large groups of plant-eating dinosaurs. Some dinosaurs ate the leaves of ancient trees known as conifers. These trees stayed green throughout the year and produced needle-like leaves or small scales instead of broad leaves. Conifers grew in many different climates and remained one of the most important sources of food for large plant-eating dinosaurs. Their branches often reached high above the ground, making them easier for tall dinosaurs to feed on than for shorter ones. Cycads were another food source. These plants had thick trunks and strong leaves that spread outward from the top. They look different from many trees growing today and were common during much of the time dinosaurs lived. Some plant-eating dinosaurs fed on the leaves of cycads, while others may have eaten the softer growing parts near the center of the plant. Their strong jaws allowed them to remove pieces of these tough plants before swallowing them. Bennettite tails were another group of ancient plants that grew in many dinosaur habitats. Although these plants disappeared many millions of years ago, they were common during much of the age of dinosaurs. Their thick leaves and sturdy stems provided another source of food for many plant eaters. The variety of plants available helped different kinds of dinosaurs find enough food even when they shared the same land. Some dinosaurs also ate fruits whenever they could find them. During the later part of dinosaur history, flowering plants became more common in many places. These plants produced seeds and fruits that could be eaten by some animals. Fruits provided water, natural sugars, and nutrients. Smaller dinosaurs may have searched among bushes and low branches for these foods, while larger animals may have eaten fruits along with leaves as they pulled branches into their mouths. Seeds were another possible food source for some dinosaurs. Many ancient plants produced seeds that fell onto the ground or remained inside cones. Dinosaurs with strong beaks or sturdy jaws may have cracked open some seeds before swallowing them. Other dinosaurs may have swallowed small seeds whole while eating other parts of plants. Seeds contain stored food for growing plants, making them rich in nutrients. Some plant-eating dinosaurs may also have eaten flowers after flowering plants spread across parts of the ancient world. Flowers were soft and easy to bite. They also contain nutrients and water. Dinosaurs feeding among flowering plants probably swallowed flowers together with leaves, stems, and small branches. Bark formed another part of the diet for certain large plant eaters. The outer covering of tree trunks was tougher than leaves, but during times when softer food became harder to find, bark may have helped provide another source of nourishment. Strong teeth allowed some dinosaurs to strip bark from trees before swallowing it. Although bark was harder to digest, it could still provide food when needed. Some dinosaurs ate twigs and small branches together with leaves. Instead of carefully removing every leaf, they often grabbed whole branches and swallowed large mouthfuls. Their digestive systems helped break down the plant material after it entered the body. Since chewing was limited in many plant-eating dinosaurs, much of the work of processing food happened inside the stomach and intestines. Many plant-eating dinosaurs swallowed stones called gastroliths. These smooth stones remained inside the stomach and helped crush tough plant material. Since many dinosaurs swallowed food with little chewing, the stones helped break food into smaller pieces as the stomach muscles moved them around. This process made it easier for the body to take nutrients from leaves, stems, and other plant parts. Scientists have found smooth stones near the remains of some dinosaurs, giving support to this idea. The digestive systems of plant-eating dinosaurs had to deal with large amounts of tough plant material every day. Plants contain strong fibers that are difficult to break down. Food often stayed inside the body for a long time while digestion took place. Tiny living organisms inside the digestive system may have helped break down some of the plant material, allowing the dinosaur to absorb more nutrients before waste left the body. Large plant-eating dinosaurs often needed enormous amounts of food each day. Their great size required a steady supply of energy to support muscles, bones, organs, and body growth. Many spent much of the daylight hours feeding almost without stopping. They slowly moved through forests, plains, and river valleys, while gathering food wherever they went. Their lives centered around finding enough plants to meet their daily needs. Smaller plant-eating dinosaurs usually required less food than the largest species, but they still needed to feed often. Their faster movement allowed them to search different places for fresh plants. Some stayed in groups, moving together as they searched for areas with abundant food. Living in groups may also have helped them stay alert while feeding, since hungry meat-eating dinosaurs could appear without warning. Young plant-eating dinosaurs often ate softer food than fully grown adults. Their smaller jaws and developing teeth made tender leaves, fresh shoots, and soft plants easier to handle. As they grew larger, they became able to eat tougher plants that required stronger jaws and greater bite force. Different teeth helped plant eaters handle different kinds of food. Some dinosaurs had flat teeth that helped cut leaves into smaller pieces. Others had rows of teeth that worked together to break plant material before swallowing. A few species replaced worn teeth throughout their lives because constant feeding caused heavy wear. Fresh teeth grew to replace older ones, allowing the dinosaur to continue eating without losing the ability to feed. Beaks were useful for many plant-eating dinosaurs. Instead of using front teeth, they used hard beaks to pull leaves from branches or clip plants growing near the ground. The beaks could remove large amounts of vegetation with each bite. Food then moved farther back into the mouth where other teeth handled it if the dinosaur had them. The height at which dinosaurs fed often depended on the shape of their bodies. Tall dinosaurs reached food that shorter animals could not reach. Others focused on plants growing close to the ground. This natural spread of feeding heights allowed many plant eaters to live in the same general area while finding food in different places. Seasonal changes affected the food supply. During wetter periods, fresh plants grew quickly and food became easier to find. During drier periods, some plants stopped growing or lost many of their leaves. Dinosaurs then searched wider areas for enough food. Some likely travelled long distances following places where plants continued to grow. Water was closely connected to food. Healthy plants usually grew best where enough water was available. Rivers, lakes, and wetlands often became gathering places for plant-eating dinosaurs because food remained available there even during drier seasons. These same places also attracted meat-eating dinosaurs looking for prey, making feeding areas important parts of the daily lives of many different dinosaur species. Meat-eating dinosaurs depended on animals instead of plants for most of their food. Their bodies were built for catching, killing, and eating prey. Sharp teeth, strong jaws, and powerful muscles helped them tear flesh from the animals they caught. Their meals supplied protein, fat, vitamins, minerals, and energy needed for hunting, movement, growth, and survival. Unlike plant eaters that often spent many hours feeding each day, some meat eaters could consume a very large meal and then go for a period before eating again. Meat-eating dinosaurs hunted many different kinds of animals, depending on their size, strength, speed, and the place where they lived. Smaller hunters often focused on animals that they could catch without using too much energy. These included small reptiles, early mammals, young dinosaurs, amphibians, and other small creatures that lived among plants, near rivers, or inside forests. Larger hunters searched for much bigger prey. They followed groups of plant-eating dinosaurs, looking for animals that had become separated, were young, were old, or had been injured. A successful hunt provided enough food to support the hunter until it needed to feed again. Many meat-eating dinosaurs also ate the eggs of other animals whenever they found them. Eggs were rich in nutrients because they contained everything needed for a young animal to begin growing. A dinosaur that discovered an unprotected nest could quickly break open the eggs using its jaws or feet. Since eggs could not escape, they offered an easy source of food when available. Some hunters likely searched nesting areas during the breeding season because many eggs and newly hatched young could be found in one place. Newly hatched dinosaurs were another source of food for some predators. Very young dinosaurs were much smaller than adults and had less strength and experience. They depended on adults for protection, but some still became victims of hungry hunters. This danger was one reason many plant-eating dinosaurs probably guarded their nests and remained close to their young after hatching. Some meat-eating dinosaurs fed on fish. Rivers, lakes, and shallow coastal waters held many kinds of fish, species that could be caught by hunters with the right body shape. Dinosaurs with long jaws and pointed teeth were especially well suited for gripping slippery fish. They may have stood near the water, waiting for movement before striking quickly. Fish provided a dependable source of food in places where they were plentiful. Animals that lived near water, such as turtles and crocodile relatives, may also have been eaten by certain meat-eating dinosaurs. Catching these animals required speed, strength, and careful timing, because many could defend themselves with strong jaws or hard shells. Even so, a hungry predator would often take any opportunity to secure a meal. Some dinosaurs searched for food among fallen logs, thick plants, or rocky ground where small animals hid. These hunters depended on sharp eyesight, a good sense of smell, or sensitive hearing to locate hidden prey. Once they detected movement, they rushed forward and caught the animal before it escaped. Small meals like these may have been eaten many times during a single day. Not every meat-eating dinosaur hunted live animals all the time. Some also fed on animals that had already died. Finding the body of a dead dinosaur provided a large amount of food without the danger and effort of a hunt. A carcass could attract many different meat-eaters, and several species may have fed on the same remains until little was left. Strong jaws helped break through thick skin and reach the flesh beneath. When many predators arrived at the same carcass, competition for food could become intense. Larger dinosaurs often claimed the best feeding places because of their size and strength. Smaller hunters sometimes waited nearby until the larger animals had finished eating. Afterward, they fed on pieces that remained. Even small scraps could provide valuable nourishment. The breakup of Pangea began during a time when the surface of Earth was changing in slow but powerful ways. Pangea was a huge landmass that joined almost all of Earth's land together. It stretched across a large part of the planet and was surrounded by one enormous ocean. For many millions of years, this great landmass remained connected. Plants spread across wide areas, rivers crossed large distances, and many kinds of animals, including the earliest dinosaurs, moved across lands that were not separated by wide oceans. Even though Pangea looked solid and permanent, the land beneath it was slowly changing. Deep below the surface, heat inside Earth continued to move rocks in the mantle. These movements slowly pushed and pulled the giant plates that formed Earth's outer shell. These slow changes eventually caused Pangea to crack and begin breaking into smaller pieces. The surface of Earth is not made from one solid piece of rock. Instead, it is made from large sections called tectonic plates. These plates fit together like parts of a giant surface covering the planet. They carry continents and ocean floors as they move over the softer rock beneath them. The movement is extremely slow. A plate may move only a few centimeters during 1 year. This movement is far too slow for people to notice in daily life. But over many millions of years, the movement becomes great enough to change the shape of the world. Heat inside Earth is the main source of this movement. Deep inside the planet, the core remains extremely hot. This heat slowly warms the rocks in the mantle above it. Although these rocks remain solid, they can move very slowly over long periods of time. Hot material rises while cooler material sinks. These slow movements create forces that push and pull the tectonic plates resting above them. As the plates move, continents also move because they are part of these plates. Pangea rested on several connected tectonic plates. For a long time, these plates stayed close together, allowing the supercontinent to remain whole. As heat continued to build beneath parts of Pangea, pressure slowly increased. The crust became stretched in some places. Small cracks began to appear where the rocks could no longer resist the pressure. At first, these cracks were not very wide. They may have looked like long valleys running across parts of the land. Over time, they became larger and deeper. When the crust stretches, it becomes thinner. As it becomes thinner, hot material from deeper inside Earth can rise closer to the surface. This rising material adds even more pressure beneath the crust. Eventually, molten rock pushes upward through weak areas. Volcanoes may begin forming along these cracks. Lava flows spread across the land, covering older rocks with fresh layers of hardened volcanic rock. These volcanic events happened many times over long periods, showing that strong forces were working beneath the surface. Scientists have found large areas of volcanic rock that formed during the early stages of Pangea's breakup. These rocks cover wide regions and show that huge amounts of lava reached the surface. The eruptions did not all happen at once. They occurred over many thousands of years as the crust continued to split apart. Every eruption added more rock to the surface while also showing that the land beneath was opening. As the cracks widened, long valleys called rift valleys formed. A rift valley develops when the land between two separating sections slowly sinks while the land on either side moves apart. These valleys often become places where lakes and rivers form. They also become paths where future oceans may eventually appear. The first stages of continent separation usually begin with these rift valleys. The movement of tectonic plates did not happen evenly across the whole of Pangea. Some areas began splitting earlier than others. Different parts of the supercontinent responded to the forces beneath them in different ways. Some regions remained connected, while others slowly moved apart. This uneven movement created different stages in the breakup process across the landmass. One of the earliest major separations took place between the northern and southern parts of Pangea. The northern section became known as Laurasia. The southern section became known as Gondwana. These two giant land areas did not suddenly move far apart. They slowly drifted away from each other over many millions of years. The gap between them gradually widened as new ocean floor formed. When continents begin moving apart, molten rock rises into the opening left behind. As this molten material cools, it becomes new ocean crust. More molten rock continues rising as the plates keep moving apart. This process slowly creates a growing ocean basin between the separating continents. The older crust moves farther away, while new crust continues forming in the middle. This process is known as seafloor spreading. Seafloor spreading played an important part in the breakup of Pangea. As new ocean crust formed, the distance between the continents slowly increased. The movement remained extremely slow, but over many millions of years, the growing oceans became wide enough to separate lands that had once been joined together. The early ocean that formed during this breakup continued growing little by little. Water filled the low areas created by the spreading crust. As the opening became wider, more seawater entered. New coastlines formed where dry land had once stretched without interruption. Rivers that had once flowed across one connected continent now reached newly formed seas. The changing shape of the land affected weather across many regions. While Pangea remained whole, much of its interior was far from the sea. Many inland areas received little rainfall because moist air from the oceans could not easily reach them. Large dry regions existed across the center of the supercontinent. As the continents slowly separated, more coastlines appeared. Ocean air could travel farther inland. Rainfall patterns slowly changed in many places. These changing weather conditions affected plant life. Some areas became wetter and supported thicker forests. Other places remained dry and continued supporting plants that could survive with less water. As climates changed, different plant communities spread into new areas while others became smaller. Animals also responded to these environmental changes. Some groups continued living on the same land for many generations. Others found their movement limited as rivers, valleys, mountains and growing seas created barriers. Populations that had once lived together slowly became separated. Over many millions of years, these separated groups developed different features as they adapted to their local environments. Dinosaurs were among the animals living during this period of changing continents. Early dinosaur groups had spread widely across Pangea because there were few large oceans blocking their movement. as the continents slowly drifted apart, dinosaur populations became isolated from one another. Different groups evolved in different regions, leading to greater variety among dinosaur species. The breakup of Pangea also affected many other reptiles, early mammals, amphibians, insects, and fish. Freshwater animals often found it difficult to cross new saltwater barriers. Some species remained on one continent while related species survived on another. This gradual separation helped create the wide variety of life that later appeared across different continents. The oceans themselves also changed during this period. As new ocean basins formed, ocean currents developed along new paths. These currents carried warm and cool water to different regions. Changes in ocean circulation affected weather, rainfall, and temperatures across the world. Marine life also responded as new habitats appeared. Sea levels changed many times while the continents continued moving. Sometimes the oceans spread over low coastal areas, creating shallow seas. At other times, the water pulled back from the land. These changing sea levels created many new environments where different plants and animals lived. The movement of tectonic plates also created mountains. When plates pushed against each other, the crust folded and rose upward. In other places, stretching caused the crust to sink instead of rise. Earth was constantly changing as different forces acted across different regions. Some mountains that formed during the time of Pangea have since been worn down by wind, rain, rivers, and ice, while newer mountain ranges formed later as continents continued moving. Evidence for the breakup of Pangea can be found in many kinds of rocks. Scientists study layers of rock that formed during different periods of Earth's history. These layers preserve signs of changing environments, volcanic eruptions, river systems, deserts, forests, and shallow seas. By examining these rocks, scientists can follow the stages of continent separation. Fossils also provide important evidence. The same kinds of ancient animals and plants have been found on continents that are now separated by wide oceans. These discoveries show that the continents were once connected, allowing these living things to spread across the same land. Later, as the continents drifted apart, their descendants developed separately. Ancient mountain belts also support the idea that the continents were once joined. Mountain ranges on one continent often match the rocks and structures found on another continent across the ocean. When the continents are placed back together, these mountain belts line up, showing that they were once part of the same larger system. The coastlines of several modern continents also fit together in ways that suggest an earlier connection. The shapes of Eastern South America and Western Africa match especially well when scientists study the edges of the continental shelves rather than only the modern shorelines. This matching shape became one of the first clues that the continents had once formed a single landmass. Magnetic evidence found in rocks provides another important clue. When volcanic rocks cool, tiny minerals inside them record the direction of Earth's magnetic field. Scientists study these magnetic records and find patterns that match across different continents. These patterns show that new ocean crust formed as the continents slowly moved apart. Earth's magnetic field has changed direction many times during its history. Each time molten rock cooled into solid rock along the spreading ocean floor, it locked in the magnetic direction of that time. The matching patterns found on both sides of ocean ridges show that new crust formed equally as the continents separated. Modern technology allows scientists to measure the movement of continents directly. Satellites and other instruments can detect extremely small changes in the positions of continents. These measurements show that tectonic plates continue moving today, just as they did during the breakup of Pangea. Although the movement is slow, it continues shaping Earth's surface. The breakup of Pangea did not happen in one short event. Different sections separated at different times over many millions of years. Some oceans opened while others became smaller. Some continents drifted northward while others moved southward. The paths they followed depended on the movement of the tectonic plates beneath them. Africa remained connected to South America for a long period after other parts of Pangea had already begun separating. Eventually, the crust between them stretched enough for a new ocean to begin forming. Molten rock rose into the gap, creating new ocean floor. Over time, the opening widened into the Atlantic Ocean. As the Atlantic continued growing, Africa and South America slowly moved farther apart. North America also separated from Europe and parts of Greenland through similar processes. Rift valleys formed first. Volcanic activity followed. New ocean crust developed as the plates continued moving. The Atlantic Ocean gradually widened between these landmasses as millions of years passed. India was once attached to Gondwana, along with Africa, Antarctica, Australia, and South America. After separating from Gondwana, India moved steadily northward across the ocean. This movement continued for many millions of years until India eventually reached Asia, where the collision helped create the Himalayan mountain range much later. Australia also separated from Antarctica over time. After breaking away, Australia slowly drifted toward its present location. Antarctica remained closer to the South Pole, where colder conditions gradually developed. The growing isolation of Antarctica later played an important part in the development of its icy environment. South America separated from Antarctica as well. As the continents moved apart, new ocean passages formed. These openings changed the flow of ocean currents around Antarctica. Over time, these changes contributed to cooler conditions across the southern polar region. The movement of continents influenced the spread of plants and animals throughout Earth's history. Land bridges sometimes connected continents for limited periods, allowing species to move between them. Later, these connections disappeared as oceans widened. This cycle of connection and separation shaped the distribution of many living things. Volcanic activity remained common in many areas during the breakup of Pangea. Rising magma created new volcanic fields, lava flows, and underground rock formations. Some volcanic eruptions released large amounts of gases into the atmosphere. These gases may have affected global temperatures and rainfall patterns for long periods. Carbon dioxide released from volcanoes entered the atmosphere during many eruptions. This gas helps trap heat around Earth. Large volcanic events may have increased carbon dioxide levels for some periods. At other times, weathering of rocks removed carbon dioxide from the atmosphere. These natural processes helped shape Earth's changing climate over many millions of years. Rain slowly breaks down exposed rocks. Rivers carry tiny pieces of these rocks toward the oceans. Some minerals react with carbon dioxide during weathering, removing part of it from the atmosphere. As mountain building and volcanic activity changed the amount of exposed rock, the rate of weathering also changed. The breakup of Pangea created many new coastlines. Coastal regions often support rich plant and animal life because rivers bring nutrients from the land while tides mix seawater. As coastlines increased, many new habitats developed for marine organisms, fish, shellfish, and other forms of life. Shallow seas spread across some low-lying regions during parts of this period. These shallow waters received sunlight across much of their depth, allowing many marine plants and tiny organisms to grow. Larger sea animals found food in these productive waters, creating active marine ecosystems. The formation of new oceans also influenced wind patterns. Air moving across growing bodies of water picked up moisture before reaching nearby land. Rainfall increased in some areas while other places became drier, because changing mountain ranges and coastlines redirected winds. The breakup of Pangea changed river systems as well. Rivers that once crossed one continuous continent were divided by rising land, sinking valleys, or growing oceans. New rivers formed as landscapes changed. Some rivers became shorter after reaching nearby seas, while others followed entirely new paths across the changing land. Lakes appeared in many rift valleys during the early stages of continent separation. Some of these lakes lasted for long periods before becoming connected to the sea. Sediments settled on their bottoms, preserving fossils, pollen, plant remains, and animal tracks that scientists study today. Animal footprints preserved in mud provide valuable information about life during this period. Tracks show where dinosaurs walked, where smaller reptiles searched for food, and where other animals traveled across soft ground. Some trackways end where changing water levels later covered the land with sediments that protected these ancient footprints. Plant fossils reveal changing forests and plant communities as climates shifted. Leaves, seeds, wood, pollen, and spores help scientists understand which plants lived in different regions, while the continents slowly drifted apart. These fossils show that some plants spread widely before separation, while others became limited to certain continents afterward. The breakup of Pangea also influenced the development of new species through geographic isolation. When groups of animals became separated by growing oceans, they no longer mixed with each other. Each group continued living under different environmental conditions. Over many generations, changes accumulated until entirely new species appeared. This process happened not only among dinosaurs, but also among insects, reptiles, amphibians, mammals, birds that appeared later, flowering plants that developed later, and countless smaller forms of life. The changing arrangement of continents provided many opportunities for populations to become separated and develop along different paths. Scientists continue studying the breakup of Pangea using many different methods. They examine rocks collected from mountains, deserts, coastlines, and ocean floors. They study fossils, volcanic layers, mineral crystals, and magnetic records. They use satellites to measure modern plate movement and computer models to reconstruct the positions of ancient continents. Ocean drilling projects recover long cylinders of rock and sediment from beneath the seafloor. These samples preserve evidence of changing climates, volcanic activity, ocean chemistry, and the formation of new crust. By studying these records, scientists gain a clearer picture of how the oceans expanded as Pangea broke apart. Earthquakes also help scientists understand plate movement. Most earthquakes occur where tectonic plates meet. By mapping earthquake activity around the world, scientists identify the boundaries between moving plates. These boundaries show where continents continue separating, colliding, or sliding past each other today. The breakup of Pangea remains one of the greatest geological events in Earth's history because it changed the arrangement of continents, oceans, climates, ecosystems, and the paths followed by countless living organisms. The slow movement of tectonic plates continues today, showing that Earth's surface remains active and continues changing through the same natural forces that first caused the great supercontinent to begin splitting into separate continents.